3 guests put in $30. But count it again and there's only 29. So where did that dollar go? Don't worry. There are no scary formulas today. Addition, subtraction, and an eye that follows the money, that's all we need. Our story begins in an old hotel. 3 guests arrive to rent a room. The price? $30. They chip in $10 each and hand $30 to the front desk. But a moment later, the manager speaks up. This room was actually $25. The manager hands the bellhop $5 and sends him off. Return this to the guests, he says. But on the way, the bellhop gets a sneaky idea. $5 doesn't split evenly among 3 people, does it? So he hands the guests just $1 each, $3 in all, and slips $2 into his own pocket. So far, it's just a petty theft story you could hear anywhere. But then someone starts doing the math, and a chill runs down your spine. Each guest paid $10 and got $1 back, so what they really paid is $9. With 3 guests, that's 9 times 3, they paid $27. Add the $2 the bellhop pocketed, and 27 plus 2 is $29. But the money they first handed over was clearly $30. So where on earth did that last dollar disappear to? This riddle is a classic that's been making the rounds for nearly a century. Not because the answer is hard. It's wrong in such a convincing way that pinning down where it goes wrong is strangely tricky. Let me spoil the ending right now. This dollar never went missing. More precisely, there never was a dollar that could go missing in the first place. It's a fake conjured out of a few numbers. First, let's carefully write out the sum that fooled us line by line. Look at each line on its own, and nothing seems wrong anywhere. At that last line, wait, shouldn't that be $30? The moment you think it, the trap springs. But here's something we need to stop and ask. Why did we feel we had to add 2 to 27 in the first place? There is actually no reason at all why that addition should land on 30. The baseless expectation that adding it all up should give back the original $30. That's what we're going to demolish today. There's one honest way to check the truth. Follow the $30 and find where it is right now, down to the last cent. So let's set the wordplay aside for a moment, and follow the money. First, the $30 goes to the front desk. From there, $25 stays in the hotel safe, and $5 passes into the bellhop's hands. That $5 then splits again. $3 goes back to the guests, and $2 goes into the bellhop's pocket. And that's everything. This picture is exactly what accountants call cash flow. Shall we check the final resting places? Hotel 25, bellhop 2, refund to the guests 3. Add those 3 numbers together and you get exactly $30. Not a single cent leaked out. The dollar didn't disappear anywhere. The $30 is simply sitting quietly in 3 places. So what vanished wasn't money. It was our vague belief that 27 plus 2 should make 30. So what exactly did that bogus addition get wrong? The key is the direction the money moves. From the guest's point of view, some money leaves their pockets and some money comes back in. The $27 the guests ultimately paid is money that left their pockets. So which side is the bellhop's $2 on? It's where part of the guest's $27 ended up. In other words, the $2 isn't new money outside the 27. It's money already inside it. It's adding a hole to a part of that same hole. It makes as little sense as adding a length to a piece of that same length. So what should the $27 be added to? Money moving the opposite way. The $3 that came back to the guests. Let's nail it down with a picture. The top bar is the $27 the guests paid. Inside it, the hotel's share of $25, and the bellhop's share of $2. As the arrow shows, the bellhop's $2 is money already inside this 27. So 27 plus 2 is a calculation that counts the same money twice. Now with 3 bars, let's see that double-counted $2 with our own eyes. On the left, the correct count. Stack Hotel 25, bellhop 2 and refund 3, and you get exactly $30. In the middle, what the guests paid. Hotel 25 with bellhop 2 on top, $27. And on the right, the bogus sum. On top of the 27, a hatched $2 is stacked one more time. The lower parts of the middle and right bars are completely identical. The only difference is that single $2 stacked again on top. And that double-stacked $2 is exactly what creates the fake number 29. One side is money the guests handed over. The other is where that money ended up. They were never meant to be added on the same line. If you followed this far, one question remains. Fine, the math is bogus, but why does it look like exactly $1 is missing? Not $100, not $0, exactly $1. It almost feels like a law of nature. The best way to unmask this dollar is to change how greedy the bellhop is. Let's call the amount the bellhop pockets B for a moment, a letter instead of a number. In the original story, that blank held a 2. If the bellhop takes B dollars, the money going back to the guests is 5 minus B dollars. And what the guests ultimately pay becomes 25 plus B dollars. Now do what the riddle tells you, and stack the bellhop's B dollars on one more time. The bogus sum is 25 plus B plus B. Compare that with $30 and the gap is 5 minus 2B. Plug in B equals 2, 5 minus 4, and the gap is $1. That famous missing dollar. If B is 2.5, the gap is 0. Nothing happens at all. If B is 3, the gap is minus 1. Now, far from money being missing, there's actually $1 left over. Sweep the bellhop's greed all the way from $0 to $5 and plot it, and this is what you get. The correctly counted total stays pinned to $30 no matter what. Money is always conserved. The dark line, though the bogus sum, swings up and down with the bellhop's greed. If the bellhop takes $2.5, the bogus sum happens to land exactly on 30, and nobody ever asks about missing money. Print out the actual values and here's what you get. Same events, same arithmetic. Yet one twist of the bellhop's greed flips the missing $1 into a leftover $1. The dollar was short simply because the bellhop took $2. No law of the universe swallowed a dollar. The puzzle maker can conjure any missing amount just by tweaking a single number. That's the surest proof this is nothing but wordplay. Once you know the answer, it's almost embarrassingly simple. So why has this riddle been hooking people for nearly a century? The trick is that it quietly lines up two flows moving in opposite directions. The $27 the guests paid is a departure. The bellhop's $2 is one of the places that money arrived. Adding departures to arrivals is as strange as adding what you spent at a store to what landed in the clerk's pocket. Lengths compare with lengths, weights with weights. That's when measuring makes sense. Money is the same. Only add and subtract flows going the same direction. That's also why a good ledger always balances. It never mixes money coming in with money going out in the same column. This riddle deliberately scrambles those columns, dressing up a perfectly intact $30 to look as if $1 were missing. Whenever you get confused, the way out is always the same. Before you add, ask, is this money that went out or money that arrived? It was just a little hotel story, and yet we've arrived at a lesson with real weight. First, the dollar never went missing. The $30 was always split perfectly intact. Hotel 25, bellhop 2, refund 3. Second, that troublesome 29 is a fake number. The $2 already inside the 27, added one more time. Third, before you add, you must ask, are these two flows going the same direction? Mix them and you can conjure any answer you like. We didn't need a single line of complicated math. We just calmly followed where the money went. One quick note on this riddle's history. The missing dollar is a folkloric classic with no single author. Similar versions appear in puzzle collections from the early 20th century, and through columnists like Martin Gardner it settled into today's hotel and bellhop form. Tricks of the same flavor are surprisingly close to home. Ads that nudge you into adding numbers to the wrong partners, articles that quietly compare against a different baseline. So when a number sends a chill down your spine, the first thing to suspect isn't a law of the universe. It's who added what to what. The missing dollar was never missing at all. It was only a shadow cast by numbers, conjured for a moment at someone's fingertips, then gone. If you enjoyed today's journey, cheer us on with a like and subscribe. See you at ELLS Lab for the next Odyssey.